So in this video, I want to talk about one of the example of SAT math problem. And the question is, in a triangle ABC, the measure of angle B is 90 degrees, BC is 16, and AC is 20. Triangle DEF is similar to triangle ABC where vertices DE and F correspond to vertices A, B, and C respectively, and each side of triangle DF is 1/3 of the length of the corresponding the side of triangle ABC. What is the value of sine of F? So before we think about this question, let's think about our solutions for that question. And in step 1, we need to draw every single triangles according to the given informations for more specific informations. And also in the second step, we only have to care about the locations of the central angles, such as, let's say there is a right triangle, and let's say the central angle is right over here. The reason why central angle is important because it makes the sine or cosine change. So in the third step, we always have to care about the properties of fractions, such as 1/3 is equal to 10/30 or that is equal to 100/300. The reason is because we have a ratio between the fractions. So before we solve for this question, let's just think about how to memorize sine or cosine. The way to memorize it is by using its first initial letters, which means for a cosine, we use C for it. And for sine, we use S for it. And all you have to remember is that for a cosine, we use C for it. And it always should be near a central angle. Let's say central angle, in this case, right over here. For C, it always starts from the hypotenuse, which is H in this case, and it goes all the way down, and it is a C for initial value of cosine, and it always should be near a central angle. And so this was cosine, and it was C for it. And all you have to remember is that the starting line will be a denominator if we form it with a fraction. So we will going to be H, and in the numerator, the ending line, which is B. And this was C for a cosine's initial value. Let's think about in terms of a sine. For sine, we use S for it, and it always starts from a hypotenuse, and it will go all the way down to the A. And this was S for initial value of sine. And if we form by a fraction, it will going to be H in the denominator, which is a starting line, and then A, which is a ending line. So all you have to remember is that we use initial values of using to memorize the trigonometric functions. Let's go to the next one. The difference between this triangle and this triangle is that the central angles locations are different. That's why we say central angles are important, which form a trigonometric function. So let's think about in terms of a cosine at first. So for a cosine, we use C for it. We always said that it should always be near a central angle. And it always starts a hypotenuse, which is H, and it goes all the way down to the A. So it will going to be H in the denominator, which is a starting line, and the ending line in the numerator, which is A. And let's think about in terms of a sine. For sine, we use S to talk about it. And it always starts from a hypotenuse, which is H, and it goes all the way down to the baseline. So it was going to be the starting line, which is H, and the numerator, which is a ending line, B. All you have to remember is that the difference between the trigonometric functions order based on a central angles. So we can think about in terms of the whole information that we got. And the first information that we got is that there is a triangle ABC, and the measure of angle B is 90 degrees, which means it will gonna be a 90 degrees right triangle. But the angle B is a angle which contains the 90 degrees, which means the middle we're going to be B. And both of them were going to be A over C, but I will just choose this angle A and this angle C. And the information that we got is that the BC is 16. So BC is equal to 16, and the AC is 20. And we know that there's a triangle DEF right over here that is similar with the triangle ABC, where verticals CE and F correspond to vertices A, B, and C respectively, which means there will be a D, E, F in an order, same thing with A, B, and C. And we know that each side of triangle is 1/3 the length of the corresponding side of triangle ABC. And we could have just using these properties that we learned how to memorize sine and cosine. We could have just defined the lengths by multiplying 1/3, and then we know that the central angle in this case is F. And this is the same case where the central angle located right over here. And we're trying to find the value of sine, which will turn into start forming hypotenuse, and it goes all the way down. But we don't have to multiply 1/3 to the both sides. It is because we could have just do right over here. The reason is because they are a similar triangle, and we know the ratio between a proper subfractions such as 100 over 300 is equal to 10 over 30, or that is equal to 1/3. This is exactly the same thing with our cases right over here. We're just canceling out zeros for a more simplified version. So either one will be okay, but if we think about it in terms of multiplying 1/3, it will take a lot of time and it is wasting time. So we can think about it in this way. It is a similar triangle, which means the angle F and the angle C are same. And then we can do a sine of it, which means the sine will start at the location of the central angles are important because it defines the sine and cosine. So the sine, we use S for it, and it always starts from the hypotenuse and it will go all the way down. So we can say that our value of sine of F right over here is the same thing with sine of C as we got right over here. And that is equal to hypotenuse. The starting line we're going to be denominator, which we're going to be 20. And in the numerator, we're going to be a ending line. But we don't know the value of it. But there is a way of finding it by using a Pythagorean theorem. The Pythagorean theorem. We know the Pythagorean theorem is a squared plus b squared is same thing with c squared, where a and b are just like legs and the c is a hypotenuse. So we can mention about it that we know the value of either one, a or b are okay except for a hypotenuse. And a, we're gonna call it a given angle, given size, which is 16 squared. We don't know the value of b squared, so we can just write it. And that is equal to c squared, which is in this case hypotenuse squared, and it is 20 squared. And the 16 squared will turn into 256 plus b squared, and that is equal to 20 squared, which is 400. And we can subtract 256 to the both sides, and then we get b squared. So b squared is equal to 400 minus 256 is 144. We can take square root to the both sides to get rid of this square. And then we get b is equal to 12. So we can say that our value of a and b is 12. So we can finish our calculation that the denominator, the numerator, which is a ending line, we're going to be at 12. But we can simplify and both divisible by a 4. which will going to be 3 in the numerator and the denominator. It should be 5. So 3 over 5. So we can say that our answer is 3 over 5. And the thing that we need to remember is that I'm going to prove why multiplying 1 over 3 to the both sides or not are same. So if you raise this a little bit for more spaces, at first we know that the sine of c right over here is 3 over 5. Let's say we're doing a sine also, we're doing this way for the initial value of s. And we know that the hypotenuse is 20, but we're dividing the 1 over 3, which means we're going to be 20 over 3. This line will going to be 16, but it is 16 over 3 because we're dividing into 3. And we know the value of 12 divided by 3 is just 4. And I'm proving why these are same. And we can say that our sine always starts from a hypotenuse and it goes all the way down, which means the sine of f is equal to the ending line. The starting line we're going to be denominator, which is 20 over 3. In the numerator, it will going to be an ending line, which is 4. And we can simplify it. It is same thing with 4 divided by 20 over 3. We know that we can take the reciprocal in order to make into a multiplication, which will go to be 4 times 20 in the numerator 3. 4 and 20 we're going to cancel out at 5 and we get 3 over 5, which is exactly same thing, same answer with our original one. So we can see that the ratio between the properties of the fractions, if you cancel it out into a similar ratio, it always should be same value. And all it did is that at first we need to draw a triangle according to a given information for a more specific answers. And all we have to think about is locations of central angles because it defines a sine or a cosine's location. Also, we need to remember that the properties of a fractions, they are same